Next, we're going to look at the exogenous lipid transport pathway. So, following the consumption of a meal, our body breaks down and digests and absorbs the dietary lipid, and this mostly occurs in the small intestine, but also involves other aspects of the GI tract, including the stomach, the liver, the pancreas, and to some extent the colon. So in terms of an analogy, I need you now to think of the small intestine as a factory that is producing particular products which need to be distributed from the factory to points of sale. And the points of sale are the cells throughout the body. So the raw materials coming into this factory are our food products. They are broken down, they are repackaged as they are absorbed into the small intestinal enterocytes, and then repackaged into triglycerides and cholesterol esters. So this is illustrated by the different colored boxes that you see right here. One referring to cholesterol, the other referring to triglyceride. And then these dietary lipids are then packaged into chylomicrons, which are produced in these enterocytes as well. And these chylomicrons are basically, the analogy would be the lorry or the delivery truck related to getting this material out of the factory and delivered to its point of sale. So once these lipids have been packaged into the chylomicron, they are then sent out through the circulatory system via the lymphatic system to the various tissues, here illustrated by the muscle and the adipose tissue. So think of the individual cells in these tissues as individual points of delivery for the products that are contained in this lorry. These nutrients are then shipped around to the individual cells, unloaded from the chylomicron, and taken into the cells via specific processes. Once the truck has been emptied of its product, this is when you now have a chylomicron remnant. In reality, trucks don't shrink as their products have left them, but in the case of chylomicrons, yes, they do. They are decreased in size, and they are recognized by receptors at the liver and removed from circulation. And so this is a general analogy that you can apply to the exogenous pathway. So this, again, is raw material coming from outside the body, entering the gut, entering the enterocytes, getting packaged into chylomicrons, chylomicrons secreted into circulation, delivered to the tissues, and these remnants then being taken up by the liver and removed from circulation. This occurs in the postprandial period, and for the most part, chylomicron concentrations will peak at around 3 to 4 hours postprandially, and by 8 to 10 hours postprandially you will have virtually no chylomicron or remnant present in your circulating lipoprotein pools. Here's a diagram which nicely illustrates this same process without the analogy of the factory and delivery truck, where you have dietary fat entering the small intestine, lipases breaking down the fatty acids and aiding in their absorption into the enterocytes, fatty acids being repackaged as triglycerides, B48, ApoB48 being produced, and the triglycerides and cholesterol esters packaged into chylomicrons and secreted into circulation, where they then interact with other tissues, and in particular the lipoprotein lipase will break down these fats again, allow these free fatty acids to be taken up by the adipocytes and stored as triglyceride within these cells. The chylomicron remnant then travels to the liver, where it's removed from circulation. And again, this is summarized here in this pathway: breakdown of triglyceride, absorption into enterocytes, packaging in chylomicrons, interaction with HDL particles to obtain ApoC and ApoE apolipoproteins. These are required specifically by the chylomicron from the HDL because ApoC is required to activate the lipoprotein lipase at the adipose or muscle cells, and ApoE is required because it is what's recognized by the receptors on the liver, which then remove the remnant from circulation. So finally, some notes on the exogenous pathway. Long-chain fatty acids are reesterified into triacylglycerols in the gut, packaged into chylomicrons, which contain ApoB48, are synthesized. These chylomicrons are then secreted into the lymphatic system, where they eventually are circulated through the body in the peripheral circulation. ApoC, ApoE, and other cholesterol esters are required from HDL while in circulation. ApoC is required to activate lipoprotein lipase, which is essential for catalyzing the hydrolysis of these triacylglycerols, producing free fatty acids and monoacylglycerols for uptake into various cells throughout the body. ApoC at some point gets transferred back to HDL. This is when the chylomicron becomes much more lipid poor, and the chylomicron remnant is taken up by the ApoB48, ApoE remnant receptors in the liver. So this is a very brief overview of the exogenous lipid transport pathway. Next, we're going to talk about the endogenous lipid transport pathway in part 3.